Hello everyone, welcome back to the another session in design and analysis of algorithms. Topic name is transitive closure. This topic you'll find in 4th unit as topic number 2. As far as this video is concerned, we'll be going to talk about what is transitive closure, and we'll take some example problem and we'll find out transitive closure of a graph. Now let's get started. The very first point of transitive closure is a directed graph, and it's also known as a digraph, is a graph whose edges are all directed. Now, assume that given vertices u and v of a digraph g dash, u reaches v. With this direction, u reaches v. That means v is reachable from u if g dash has a directed path from u to v. And a digraph G dash is a strongly connected if for any two vertices u and v of G dash, u reaches v and v reaches u. Now, there are two kinds of digraphs, that is cyclic and acyclic. What do you mean by cyclic graph? The name itself, it says that a directed cycle of G dash graph is a cycle where all the edges are traversed according to their respective directions. Now it forms a cycle according to their respective directions. Now 0 to 1, 1 to 2, 2 to 3 and 3 to back 0. So it forms a cycle. Now this is called as cyclic directed graph. Now what do you mean by acyclic? Acyclic is what? That is also directed graph. It is also digraph or directed graph. And you'll find the directions from one vertices to other vertices. But this is a digraph G dash is acyclic if it has no directed cycle. That means, look at this, you will not form any cycle with this direction. So A to B, B to D, D to C, and there is no out edge from E to the other. So we were stopped here. So it doesn't form a cycle, hence it is called as a cyclic directed graph. And this is what strongly connected graph, and this is what directed acyclic graph. Now let's understand about what is transitive closure. What exactly we'll be going to do as part of this transitive closure. Assume that transitive closure of a digraph G dash is the digraph of G dash star such that the vertices of G dash star are the same vertices in G dash, and G dash star has an edge u comma v whenever G dash has a directed path from u to v. That is, G dash star is defined by starting with the digraph G dash and adding in an extra edge u comma v for each u and v such that v is reachable to u. Now, we'll take some example and we'll do the thing. So before we'll take some example, let's understand the process of finding out transitive closure. With this definition, you might have understood this, that we will be having two kind of graphs. So one is your digraph, the other is also a digraph. Now we'll find out this u comma v reachability, and this is what your transitive closure from the given graph. Now this process will perform in series of rounds. That is, let G dash be a digraph with n vertices and m edges. The transitive closure of G is computed in a series of rounds. Now that how it will be get performed, I'll just recall this topic. All pair shortest path problem is there, no? So there we were seen about the same problem is also called as Floyd-Warshall algorithm. There we used to calculate possible edges from each vertices. Now we will be going to do the same as in all pair shortest path, that we'll be going to find out the reachability matrix from each of the edge, each of the vertices. Now let's see how we will be finding out that using with some example. Now the example is, consider the digraph G dash. The digraph is having 6 vertices 1, 2, 3, 4, 5, 6, and these are the edges. As I told you, this is a digraph, directed graph. Now, this directed graph is having the edges which are from 1 to 1 to 2, and it is from 1 to 3 and 3 to 1. So whatsoever edges I can see from this graph, that were I wrote here in E. Now compute the transitive closure G dash star. So now G dash star is what? Transitive closure. G dash is what? Directed graph or a given graph. So we are going to find out G dash star from G dash, where vertices will not get changed. We'll have the same vertices. But the difference in normal graph and transitive closure graph is what? You will find the reachability of each vertices. That only will get changed in transitive closure. That's what the name is written as a closure. Now we'll see the solution, how I'm finding out the transitive closure G dash star. Now adjacency matrix for G dash, that means look at this graph and find out the adjacency matrix. So adjacency matrix, how you can find it out is from the graph 1 to 1 it is 0, 1 to 2, do you have any edge? Yes, the direction is there. So you can figure it out as 1. So can you find any edge from 1 to 3? Yes. Any edge is there from 1 to 4? No. There is no edge from 1 to 4. There is no edge from 1 to 5 and 1 to 6. And these are what the values where I am writing it as 1 when I found there is an edge. I am writing 0, there is no edge. Right? Now you can find it out the same. Can you see any edge from 4 to 1? No. 4 to 2? No. 4 to 3? Yes, that I have an edge from 4 to 3. And 4 to 4? 0. 4 to 5? 0. 4 to 6? 1. And 5 to 1? 0. 5 to 2? 0. There is no edge from 5 vertices. So I am making all the values of 0. And 6 also same, only it is having edge from 6 to 5. So remaining all are zeros. So this is what your cost adjacency matrix or adjacency matrix of this G dash graph. So to get G dash star graph, now I am going to get G dash star. What do you mean by G dash star? It is also a directed graph where it belongs to this G dash. This belongs to this G dash, where the vertices will be common, same vertices will use, but coming to the edges will follow the reachability from one vertex to other vertex. If U is reachable to V, if V is reachable from U, then we'll mark it as it is reachable and it is closer, that it is closer from one vertex to the other vertex, and we'll figure it out with 1. Right? Now, so maybe we will not see the direct edge. Look at this 1 to 4, there is no actual edge. The direct edge from 1 to 4, it's not there. But 1 is reachable to 4, 4 is reachable to 1 through 2. So we'll be going to perform some sequence of rounds to find it out. What are the reachability vertices through which vertex? That I'm going to see. Now, I'm calling this, the first is what? T0 I'm calling as. Okay. T0 is what? Reachability matrix of cost adjacency matrix. Okay. T0 is what? Reachability matrix. Now let's see. So in reachability matrix, especially in transitive closure, we will have self loop 1 to 1. You will be marking as 1 because 1 is reachable to 1. Okay. Now 1 to 2 it is already given, 1 to 3 given, 1 to 4, 1 to 5, 1 to 6. Now, so in transitive closure you have to find it out closer vertex. Now 2 to 1 there is no closer, so 0. 2 to 2, yes, it is reachable. Now 0, 1, 1, 0 and 0, 0 it is reachable, and it is 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 1. So what I did, how I got this T0 of G dash star? T0 is what? first transitive closure. 0 is first one, first transitive closure. So whichever is having reachable, that we were marked as 1. Now let's find out T0, T1. T1 means, here I wrote it is 1. So 1 indicates if 1 is the intermediary vertex to reach any other vertex. Now let's see, 3 to 2 there is no edge, correct? But 3 is reachable to 2, 2 is reachable to 3 through 1. So I am making T1 transitive closure. So this 1 indicates the vertex which is intermediary 1 to make other vertex reachable. Now, so 1 is intermediary to what? Only for 3 to 2, correct? Now I am just making this. Why not 2 to 3? Yes, obviously you can ask me this question. Why not 2 to 3? Why only 3 to 2? Because you have to find it out the direction. 3 to 1, 1 to 2 and 2 to 4 is there, right? Now 3 to 1, 3 to 2. So I can reach this 2 from 3. I cannot reach from 2 to 3 because there is no direction. In that way you have to think. Now, so 1 to 1, yes it is reachable, 1 to 2 reachable, 1 to 3 reachable. Same matrix of T0 I am just taking, including this 3 to 2 value which is 1 because it is reachable through 1. So remaining all the values are same as your T0. Now I am updating T2. T2 is what? 2 vertex should be reachable. Through this reachability, I have to reach the other vertices. Now we'll see for which 2 is reachable. Now, so I can go to 4 through second vertices. That means 1 to 4 I can reach through second vertices. That means one vertex is reachable to 4 through second. So 1 to 4 value will get updated with 1. Earlier it was 0. You can check. Now 1 to 5 also it is reachable through 2. That's what it is also updated with 1. And 3 to 4 also reachable with 2. Then that's what it is updated. Next 3 to 5 through 2. Now it is T2, transitive closure through second vertex. Now we'll find out with third vertex, with fourth vertex. When you find transitive closure through third vertex, you can make this reachability figures 1 to 6, 4 to 1, 4 to 2 and 4 to 5. So for all these 3, you have to take intermediary vertex which is 3. And all these values are updated in T3 matrix as 1. The same. When you see this T4, T4 is what? Fourth vertex is intermediary. That means to reach from one vertex to other vertex, we are taking the intermediary vertex. Through that intermediary vertex, I can reach from U to V, or else V is reachable from U. So, if I am making this with fourth vertex, then 2 to 1 is reachable, 2 to 3 reachable, 2 to 6 is reachable with the vertex of 4. Now, you can see the same with 5. But unfortunate thing is what? If you see the graph, you will not find any edge from 5 to the other vertices except of 5 to 5, that is reachability factor. And 6 to 5, you can find that matrix. So, the same values will come down. The same values. So, finally, transitive closure is what? Now, this matrix I am updating with 6 vertices. That means 1, 2, 3, 4, 5, 6. Transitive closure finally with all the vertices is this. So what we did is we have to find it out reachability from one vertex to other vertex in the direction. Okay, right. This is about transitive closure. Thank you all.